Hello my dear students, welcome to another lecture of an induction motor which is based on the inverted induction motor. So in this lecture we are going to start our discussion with the topic of inverted induction motor, right? uh, in last lecture, what we did in last lecture, we had studied about the rotor frequency of the normal induction motor, and also we observed and we derived how rotor frequency is induced on the rotor side of any normal induction motor. Why we called normal induction motor? Because and what is the difference between the normal induction motor and inverted induction motor? Guys, in case of normal induction motor, we have generally supplied the three-phase AC voltage on the stator side of an induction motor, and there we are going to short circuited the rotor terminals through the external resistance R. Okay, that is called a normal induction motor. But today we will discuss about the inverted induction motor and how inverted induction motor operate. This is the reverse process of the normal induction motor, right? So first we will see the circuit. First of all, we will see the circuit diagram of the inverted induction motor. So this is the circuit diagram of the inverted induction motor. As you can see that on your screen, in any induction motor there are two main important part. First part is called a stator and another part is called a rotor. But in case of inverted induction motor, we have generally supplied and we are going to supply the three-phase AC voltage on the rotor terminals of the induction motor, right? So in inverted induction motor, we used three-phase AC source voltage on the rotor. This is the rotor terminals. This is the rotor terminals of the induction motor, and at any rotor terminals we have a shaft in which we can use to lift up the mechanical load. Okay, so in case of an normal induction motor, this three-phase AC sources is generally fed to the stator side, but in case of inverted induction motor, three-phase AC source is fed on the rotor side of the induction motor. And another name of the inverted induction motor is called a rotor fed induction motor. Rotor fed induction motor, right? This is the another name of the inverted induction motor. And in case of inverted induction motor, we are going to short circuited the terminals of the stator side by using the external resistance R, right? By using the external resistance R. So what points of the inverted induction motor should be remembered? First point is that when an induction motor is supplied by three-phase AC source on the rotor side and the stator terminals are short circuited through resistance, that type of induction motor is called as inverted induction motor. Is called as inverted induction motor. or we can say that rotor fed induction motor, right? Actually, this type of arrangement is only possible for slip ring induction motor, but this kind of arrangement is not possible for a squirrel cage induction motor, because in case of a squirrel cage induction motor, there is not such a kind of arrangement from where we have to easily supply the three-phase AC sources on the rotor terminal. But in case of slip ring induction motor, the arrangement the arrangement of the slip ring induction motor is like that from where we can easily supply the three-phase source on the rotor terminal of the induction motor. So 2 points are most important points regarding the inverted induction motor. Why we call this type of induction motor is called inverted induction motor, because when an induction motor is supplied by three-phase AC source on the rotor side and the stator terminals are short circuited through resistance, so this type of induction motor is called a rotor fed induction motor or inverted induction motor. And the second point is that this type of arrangement is only possible for the case of slip ring induction motor, but not for squirrel cage induction motor. So what are the steps are generally followed to the inverted induction motor? Let us see one by one. First, step 1 is that a three-phase AC source of frequency F is connected on rotor, right? Due to which rotor produces a rotating magnetic field. By the help of three-phase AC sources, rotor produces a rotating magnetic field, and that rotating magnetic field rotate at synchronous speed in RPM, ns and RPM with respect to rotor. So speed of the rotating magnetic field is ns with respect to watt with respect to rotor, right? Another thing is that synchronous speed is generally, or synchronous speed, the expression of the synchronous speed is 120 f in 120 into f upon p. Here f is the frequency, and p is the number of poles. Okay, guys, if anyone asks in the paper or in interview what is called a synchronous speed, thus the answer is that the frequency, the conversion of electric frequency into mechanical speed in RPM, that is called a synchronous speed. So the rotor produces a rotating magnetic field that rotate at synchronous speed with respect to rotor, and that is equals to 120 into f by p. Next step is that whatever the rotating magnetic field produces with the help of three-phase AC supply, that rotating magnetic field goes to cut the stator conductor, and stator conductors induce EMF, and due to short circuited, okay, whatever the rotating magnetic field produced with the help of three-phase AC sources on the rotor side, that rotating magnetic field goes to cut the stator conductance, and due to that the EMF is induced on the stator side with the help of short circuited on the stator side, and with the help of short circuited the stator produces a current. Okay, stator produces a current. This is the step 2, right? Another step is that to reduce the relative speed. Okay, to reduce the relative speed, here relative speed is represented by this. With respect to stator, rotor rotates in opposite direction to the magnetic field. Okay, so in case of inverted induction motor, the rotating magnetic field and the direction of the rotor both are follow in the opposite direction. Both are rotate in the opposite directions, right? Both are rotate in the opposite direction. Both are rotate in the opposite direction. So these are the steps which are generally followed in case of an inverted induction motor. Now next, here you can see that the arrangement, the front view of this is the front view of an inverted induction motor. So guys, in this diagram, diagram we consider the rotating magnetic field rotate in anti-clockwise directions, right? So whatever the torque is developed on the stator side, on the rotor side, that rotor is always rotate in the opposite direction of an rotating magnetic field, that is clockwise, right? Okay, so in case of an inverted induction motor, the rotating magnetic field and the torque and the rotor rotate, the direction of the rotating magnetic field and rotor both are in opposite direction. But in case of a normal induction motor, rotor magnetic field and the direction of a rotor both are rotate in the same directions. In case of a normal induction motor, rotor speed tries to catch the synchronous speed, right? So this is the always keep in your mind that in case of an inverted induction motor, the rotating magnetic field and the direction of the rotating magnetic field and the rotor both are rotate in the opposite direction to each other, right? So here in induction motor, here first point is that in induction motor, the rotor in induction motor, the rotor rotates in the same direction as the rotating magnetic field. But in case of inverted induction motor, what happened in case of inverted induction motor? The rotor always rotate in the opposite direction to the magnetic field. So here the slip is what? Slip is the ns minus nr upon ns. Ns is what? Ns is rotating magnetic field, and nr is what? Speed of rotating magnetic field, and nr is what? Speed of the rotor. But in case of the inverted induction motor, ns means the speed of rotor magnetic field with respect to rotor, that is represented by the ns, or you can say it at synchronous speed. But in case of the normal induction motor, the ns is called, the synchronous speed is called speed of the rotating magnetic field with respect to stator. So this is the basic difference between the synchronous speed of the normal induction motor and synchronous speed of the inverted induction motor. In case of normal induction motor, synchronous speed is defined the speed of rotating magnetic field with respect to stator. But in case of inverted induction motor, the synchronous speed is defined the speed of rotating rotor magnetic field with respect to rotor. Because in case of inverted induction motor, three-phase supply is fed on the rotor side of the of an induction motor. That's why whatever the rotating magnetic field is produced, that magnetic field always give the value with respect to rotor. Right. Now next is, whatever the rotor rotates in rpm, that rotor speed is represented by nr here. Right. Is it clear? Okay. And speed of rotor magnetic field with respect to stator is ns minus nr equals to s into ns. So let us derive the speed of the rotor magnetic field with respect to stator. How it comes ns minus nr? Right. So for derive the speed of rotor magnetic field with respect to stator, let us take an example of moving car. Let us example of moving car. This is the car in which one boy is standing on the roof of the car, right? And the car itself is considered as a rotor. The car itself considered as a rotor, and the boy who is standing on the roof of the car, this boy is considered as a rotor magnetic field. Right. And the ground, and this ground from where the car is moving, this ground is considered as a stator. Right. Now this boy, the speed of the boy on the roof of the car with respect to rotor, the velocity of the boy with respect to rotor is v1. Right. So speed of the rotor magnetic field with respect to rotor, speed of the rotor magnetic field with respect to rotor means speed of the rotor magnetic field with respect to rotor is ns. Right. And the velocity of the car is move in the opposite direction of the velocity of the boy. So this velocity of the rotor is considered as a nr here. Right. This is the speed of the rotor, and this is the speed of the rotor magnetic field. So the speed of the rotor magnetic field, so speed of the rotor magnetic field or velocity of the boy with respect to ground. Okay, what will be the velocity of the boy with respect to ground? That is called the relative speed of the magnetic field with respect to conductor. Right. So the velocity of the boy with respect to ground is relative speed, which is equals to v1 minus v. But in case of an induction motor, this becomes ns minus nr, right? As simple as that. So the meaning is simple. The speed of rotor magnetic field with respect to stator, what will get, because this minus sign indicates the opposite direction of the both the object, car and boy. Okay, so that's why the speed of rotating magnetic field with respect to stator will give the value of the ns minus nr, and which is called a slip speed, and that will be the value of slip into synchronous speed, right? Okay, now next is frequency induced. Next is frequency induced in stator is equals to P into S into ns upon 120. So whatever the frequency is induced on the stator side of the inverted induction motor, that is that will give the value of slip speed, that is S into ns. S into ns, right? So guys, slip in case of an induction motors, it doesn't mean the slip is equals to the ratio of the ns minus nr by ns. No, the actual definition of the slip is the ratio of the relative speed of magnetic field with respect to conductor to the synchronous speed, right? So generally in case of a normal induction motor, the relative magnetic field is called stator, and conductor is called a rotor. But in case of an inverted induction motor, what happened? Magnetic field is produced on the rotor side, and conductor means stator, right? This is the most important thing regarding the normal induction motor and inverted induction motor. Now next is the relative speeds of the normal induction motor. Now here whatever the speed of the stator with respect to itself, whatever the speed of anything with respect to itself, it will always give the value of 0. So here as simple as that, speed of the stator with respect to itself is always give the value of 0. Speed of the rotor with respect to itself, rotor, this will also give the value of 0. And similarly speed of the stator magnetic field with respect to stator magnetic field is 0, and speed of the rotor magnetic field with respect to rotor magnetic field is 0, right? Now next is the speed of stator with respect to rotor, right? Simply when we are going to the speed of the stator with respect to when we are going to subtract the speed of the stator and rotor, that will give the value of this. Okay, simply the second column is the actual velocity are given. Okay, the second column is actually have the value of the actual velocity of the stator, rotor, stator magnetic field and rotor magnetic field. So simply when we are going to subtract the stator minus rotor, then it will give the speed of the stator with respect to rotor. In similar way, speed of the stator with respect to stator magnetic field, simply 0 minus ns, and similarly here speed of the stator with respect to rotating magnetic field. Rotating magnetic field in case of normal induction motor is called ns. So this is all about given the value of actual velocity. And this all about given the value of velocity of observer, right? So speed of the rotor, similarly speed of the rotor with respect to rotor, simply rotor minus rotor speed is 0. And when we are going to calculate the value of speed of rotor with respect to stator magnetic field, simply nr minus ns, which is give the value of minus s into ns, right? And in fourth row, speed of the stator magnetic field with respect to rotor, which will give the slip speed, that is ns minus nr, and stator magnetic field with this, and the speed of the stator magnetic field with respect to itself is always give the value. And similarly speed of the stator magnetic field with respect to rotor magnetic field or with respect to stator magnetic field, this will always give the value of 0. So this is the very important table regarding the table of the relative speeds of normal induction motor. In similar manner, relative speeds of inverted induction motor, simply here speed of stator with respect to stator means speed of stator with respect to itself always 0. It is also give the value of 0. It is also 0. It is also 0. Similarly, speed of stator magnetic field with respect to another magnetic field, rotor magnetic field, it will also give the value of 0. Right? Speed of rotor, why here the speed of rotor is minus nr? Because in case of inverted induction motor, rotating magnetic field and rotor, the direction of the rotating magnetic field and the direction of the rotor both are in opposite direction. That's why the speed of the rotor with respect to stator here minus nr. Speed of the stator magnetic field with respect to stator is s into ns, and the speed of the rotor magnetic field with respect to stator, it will also give the value of s into ns. Because this expression, speed of the rotor magnetic field with respect to stator, this expression we have already discussed, we have already derived in the previous slide of this PPT, right? So this is all about the relative speed of the inverted induction motor. So always keep this formula in your mind. If you know the value of the first second column of the relative speed of the stator with respect to stator, then you will easily calculate the other relative speeds of the normal induction motor, right? So finally, in case of inverted induction motor, the roles of stator and rotor are interchanged. That is why SF frequency is produced on the stator and F frequency on the rotor. So these all about the lecture of the rotor fed